machine somewhere, and they are bringing them all together, or it's bringing them all together in a centralized network so that they can communicate among themselves. That is the essence of a switch. So whilst a switch is handling the various devices in one network, a router is connecting that whole network to other networks. That's mind you. But then the switch has a brother called hub. I think someone mentioned hub as a device in there. Okay, I'll show you that. This hub here was mentioned. The switch has that as a brother. Of course, the hub even came into existence before a switch came. Now, what does the hub do? A hub also has its nature as the switch, because it also has these ports, but it may not have as many as a switch will have. Okay, its hub is not as advanced as a switch, even though they are serving the same purpose. The purpose of a hub is also the same as what a switch is doing, enabling connection to other machines. The same purpose. But then the challenge is this: a hub is not intelligent, but a switch is an intelligent, smart device. What does it mean? Now, considering this diagram on the screen, know this, that I've already mentioned this, that all these cables are connecting to devices, enabling them to share resources or to share information or communicate with other devices on that same network. That is what that switch and the cables are doing in the switch. Now, if this were to be a hub, now what will happen is this: if, assuming computer A in the network is sending information to another computer in that network, like say computer B, a hub is not intelligent to know exactly the destination point of the message. So the machine A will send the information, but a hub cannot easily detect which machine must receive that particular message in by itself. So what it will do is this: it will broadcast that message into the whole switch, so that every connection into the switch, every machine which is connected to the switch, will have a field signal that there is some sort of message in circulation in the switch. But then only the machine who the message is intended for will be able to access the message. The rest can only have a signal. There will be a blow-through signal, a broadcast signal that will go through all the machines that there is communication ongoing. But it will take only the receiver or the one who that message is for to now access the message. The others can't access it. They can only have that broadcast field that it's in the network. But the question is, the moment you broadcast or you send that message and it's going through all the systems, what if at the same time someone is also trying to send another message? There will be a collision, because the signal is coming in and the signal is coming out, and it's going through all the networks. So when he also sends, it will be broadcasted into all the network again. So you realize that there will be a jam up, there will be a collision, there will be collisions everywhere, and that will create a serious traffic in the network. That'll be a problem. That's what a hub will do. So for a hub, if I'm using a hub and I'm using it for just about 2 or 3 machines just for the sake of communication, that's fair enough. But for huge companies or big companies, or for something beyond just 2 or 3 or 10 and beyond, you cannot use a hub, because you will experience tough time with your network. But then the best is the switch. Now, how will the switch be different from the hub in this case? Now, the switch is intelligent, it is smart. So when someone sends an information from one machine to a different machine, It has not to broadcast it through the whole switch. No, nobody even will have a feeling that there's communication, because computer A will send directly in path to the machine that must receive it, and it will not be going through all the other systems. No, it's just between him or one machine and the other. It's like just like you go into a class to get someone, fetch someone, to call someone. The class may have about 1,000 students. Okay. Now, when you get in there and you want to locate a particular student in the class, you may just go pick the mic and then just broadcast it. I am in search of Samuel. I am in search of Kwame. Now, at that time, everybody in the class will get to know that you are in search of Kwame. But then it's only Kwame who will stand up and come. But then by the time he comes, everyone has already received the signal that Kwame is being searched for. Now, that is what a hub will do. Because it is not smart to know exactly who Kwame is for me to go to him directly. But then a switch says that no, for me, I know the person directly. I know him. So when I get to the class, I don't need to broadcast it to the whole class. I will walk straight to the person and call the person out. Now, no one will even have any signal that I am in search of this Kwame. That is smartness. So switches are what we use today. We don't use hubs for huge networks anymore. But then we use switches because they're smart and they're intelligent. And that's what they do. So that's the purpose of a switch, and that's the purpose of a hub. These two devices in the network. This is what they do. They are all to serve the purpose of connecting devices within a particular local network. But then one is smart, intelligent, and one is not. So appropriately, it is switch we use in networks today, not hubs. Okay, now with that said, let's look at a bridge now. Now, let's take it from this point. There is, let me maybe try to use diagrams sometimes to get the concept clear. Let's see this. Assuming we have this as the server room. There's a server room here where you may have your switches. Okay, let's say this in this room, and let's put it this way. You have a switch in this particular room here. Then there's another office somewhere here, which also may have its own switch for the connection. So you see, maybe the human resource department may have 20 machines. They will connect all their machines. And the finance department may also have their machines. They will also connect all their machines to one switch. And then they can create a backbone connection between the two switches. That means that we have now tried to bridge the two switches together, or to bring them together. That is what may be done. So look at this, for instance. I may have all these as machines, maybe the human resource. So this also be one, this must also be one. So these are machines in the human resource. Now this is a switch. Okay, this is a switch. Let me get text here. This is a switch, which you have here. Sorry, switch spelled. How do we spell switch? Switch, okay. Switch, okay. It's strange. Okay. So we have our switch here. Now, these are the machines we have within this network. So these ones here are connected to them. This to here, the switch. Then this one too, from here to the switch. So connected to the switch here. Then this one here, also to the switch. Now in this case, those machines all in the switch are one aspect of the network in a company. The same thing may happen to the department here. Another department is also here. Then we have them also here. then they will also have their own network here. Not a network per se, but just a branch of the company's network also here. Because you see, for the sake of proximity, you can't just connect them all into one switch. The human resource switch, the human resource machines are in a different room. So that's what may happen. Then you connect all these machines here to this particular switch here. It also has its own here as well. Now, if these two machines here, if these two places, this human resource and this one here is, let's say, the finance department, there can be a backbone cable which is now connecting both here, a switch from here to a switch from this side. Then it has now linked up these two switches, virtually making all these machines to be working in one network. That is what is happening now. But then, assuming that all these connections, all these connections must be connected to the server of the company. The company will have its one server, of which all of these must be connected to before you can browse. Okay, so let's say this one, all these ones are here. It's a diagram. Then we have the server room, which has the servers. Now, all these ones here will have to connect to the server room from one point. Okay, so all these cables here, switches here, may have to connect from here to the switch here, and then from here, this side to the switch at this point. You may need that to be the case, because this is where the server is found. So if you don't all connect to this place, you cannot browse the internet. It is only when all these places have been able to connect to the server room, then they can all browse the internet. So that's where the gateway is found. But unfortunately, the distance between the departments of finance and department of the human resource to the server room is extremely far, very far. If we are thinking of using such cables to connect them to this place, we may be in trouble. Yes, because the cables cannot be running over the heads of people who will be working around the company's campus or the company's environment. You can't be using a cable to connect straight from here to this place, from this place. No. So in that case, what we can do is this. Now we can create different a sub network over here and a sub network over here, and connect all the sub networks as we have done to the server room. But because we can't rely on cabling, because even for the cables, the RJ45 cables, the length it can actually cover to enable transmission of packets or signals will only have to be 100 meters. Anything which goes beyond 100 meters, you are likely to experience what we call attenuation. The packet will begin to drop. So you send a message and it will not even get delivered because the cable is too long for the transmission. So what do you have to do? Now, we go in for bridges. Listen carefully. We go in for bridges. So there will be a bridge. This one here, this place here, will go in to get their bridge. And they will locate their bridge on the building of this block that is a part of. So they may go in for this one. This is their whatever. Bridges may come in different shapes. Yes, they come in different shapes. Let's say this. This is one. Okay, so we'll use this one here. Good. So this is their bridge. Now there is another bridge on the server. I don't need this cable here. There will be another bridge on the server here. on the ships here. Then they also have their own this. Okay. So it also have to be on their own here, like this. Okay. So then this one, the aim is to connect this particular device here, or the devices here, the switch here, connect it to the server room or the switch there. But we can't use cable to connect from that place, from this place to this place. So we locate a bridge here. There's a bridge, there's a bridge. Then these bridges will now be made to face. We call it, it must face, they must be in the line of signal. I mean, the signals must face each other. Now, when this happens, then it means communication is actually possible or it's ongoing. Then the two here can now begin to transmit information. Mind you, they are working in line of sight. We call it line of sight. Okay, Manuel.
Yeah, yes, sir. Please,
Yeah.
I want to be clear or something.
Good, go ahead.
The bridge, are they a very big device, and where exactly do we fix them? Is it in the room or on top of the roofing?
Okay. Okay, so the bridges are not placed in your rooms. They are usually positioned on top of a building where that device is, where that network is located. Now, the reason for which it is placed on the building is this: you are transmitting signals from your particular branch to the main server room. Now, if it comes beneath, buildings can be an obstacle to proper transmission. Trees can be an obstacle to transmission. So you position it at a point where we know that it is the highest we can get in trying to swerve the trees and the buildings, which may exist in between the server room and this one. Yeah, that's what we position there. So we don't position bridges in rooms. Let me try to, I think I'm trying to get a picture of a bridge at work. Then I'll just let me see if I can get, I think there was something here. Let me try to get one for you to see exactly how sometimes they are working or they behave. Okay, maybe I may have to use this one. Okay, let's see this. So for example, let me put this one here on the slide. Look at this one, for instance. Okay, there's a bridge. There's a bridge. These are wireless bridges. So they are actually connecting the device. They are connecting the network within this particular building. They are connecting this whole network to the server room or a particular network they are in need of. That's what it is happening. So it's like this one here is representing that bridge here, this thing here. But then they work in what we call line of sight. LOS. That means that they must be in line of sight. They must meet each other. Let me see if I can find another image which will also help understand this much more better. They must always meet in line of sight. They can get one over here. I'm coming, just a minute. Okay, maybe this can be another demonstration here. What you see? Okay, let me get this one first. Okay, so okay. Okay, let me get this. Let me put this one to here. Just right here. Okay, so look at this one too. Good. Now look at this. This is the branch office. This one here is the branch office. Okay, this is the branch office. And this is the main office where the servers are found. That means that the internet itself is here. So even if there was another branch office here, they will also still have to connect to this one before this branch office can access the resources of the company. So this one branch office, so let's say this is the finance office. But this branch office will need to access the servers of the company. And this is where the servers are located. They can't connect a cable from their switch here all through to a switch here to get access to the server. Because for all you know, the distance from here to this side is a whole huge number of meters. Huge. So that will be totally impossible. You can't connect that cable because, as I've told you before, cables have limitation when it comes to the proximity they can cover. They are limited. So here, because of that, we have positioned a bridge here. This bridge here is a receiving bridge, and this one here is more of a transmitting bridge. So these two are met in line of sight. This is the line of sight transmission. We call it the line of sight transmission here. Okay, now this line of sight, this zone, this particular zone here is called the Fresnel zone. F-R-E-Z-N-E-L. F-R-E-Z-N-E-L. It is called the Fresnel zone. In fact, let me just pass this funny statement. Those who are doing computer science in masters, maybe those who are furthering in computer science, masters in computer science and the rest, the amount of mathematics which exists in this zone are very complicated, very complex, because a lot of calculations occur in this Fresnel zone. Yeah, that's I said, it's a funny comment I was just passing. Huge mathematics in there, and that is what those who are doing deeper learning into computer science actually have to study, because they should understand the transmission times. They must understand a whole lot about how the packet gets transmitted from one point to a different point before you know that it is safely delivered to the other end. Otherwise, you may always think your message has been delivered, but it's always stuck somewhere. So all these things will need a lot of calculations to ensure its effectiveness. That's what a bridge is for. So a bridge, instead of using a cable to maybe connect a switch for a switch here or something, you get your branch office own network to connect to the main network through a bridge, then you are there. So that is the purpose or the reason for that particular device called a bridge. When it comes to UCC, for instance, so it is obvious to understand, I'll come to UCC's case. It's obvious to understand that this branch office could have more than one of the bridges on this pole. Now, because the branch could be at this point, in that case, that a bridge will have to be positioned to meet its line of sight here. There can be another office here that also need this access, and that one too. So one pole like this can have a number of bridges positioned on it. Each of them must receive a signal or signals from a different branch. So when it comes to UCC, for instance, that particular building, the science block, which has the main servers in there, on top of the building, we have a similar thing like this, which has a whole lot of outings in there. That is really happening in there. Okay, yeah, Senna.
Sir, please, with the bridge connections, is it interregional or is within a region or a district? Let's say we have one company in Accra and another in maybe Tamale, or
okay,
bridge connects them.
Okay, yeah. So in terms of the strength of bridges, we have them in different types and different models. We have bridges which may not necessarily have to travel very long distances. Like for instance, let me give an example. For instance, considering the case of these, how do you call it, communication. Let's say if I want to make a call from here to someone else in the country or even beyond the country, the call does not go to the person directly. It goes through processes. That means that the various masts that we find on our roads are those ones which are receiving the signals and pass them over to the server room. There should always be a switching room. That switching room is the server room of the MTN office. It may be in Accra. So when I make a call, it must go to that office in Accra before the call is returned to the receiver. If not, it doesn't get there. But then the distance from my position in Cape Coast to the server in Accra, if I make a call, I don't expect it to be able to travel from here to that place directly. It will not, because it is not having that strength. Now, in that case, there has been the positioning of different masts at different places, so that if I make a call right now, the closest mast will pick the signal. Now, in picking the signal, it will make an attempt to deliver the signal to the server room in Accra or the switching room in Accra. But then the distance from here to Accra it will flow its dough. But by the time it gets to a particular point, the signal will begin to attenuate or get weak. And it has been strategically positioned that by the time that weakness begins to set in, there will be another mast which has been positioned there to now pick the signal and add more strength to it. And then it will boost it again and send the signal continuously to forward it. Then it will continue and continue and continue until it gets to the switching point. So we have other devices which are also strong enough to boost signal strength from a point to a much more longer distances than a shorter one. So we have them in different models and different types. We have bridges that can cover long distance ranges, and we have those which are made for very short distance ranges. But if you look at the model, I wish I could get you some other images which you could see some of these models at work. Some are not really that strong to carry data from, for far distances. Others are also able to do that. I hope it's clear, Senna.
Yes, sir. Thank you.
Okay,
sir.
you're welcome. You're welcome. Okay, so that's exactly how these devices really work. They are very, very powerful. Okay, so these are done because we can't set up networks when we are not putting the right device at place. Very important. Okay, Melmark.
Thank you, sir. Regards to the answer you were giving about MTN, or like, because the sister asked about whether the bridge is it within a local area. Like he was citing an example of whether it's within maybe Bolagatanga and then another region, or like, and it's a perfect explanation, well understood. What I want to chip in is how do we connect that one to repeaters? Because for an example that you gave, it's like there are different capacity when it comes to the bridges.
Okay.
And then I want to understand that one and just opposing it with repeaters.
Okay.
Based on the MTN thing that you also gave.
Okay.
Because I know that repeaters also kind of amplify signals.
Okay. Okay. Okay.
Okay.
Thank you very much. We are looking at a case where a repeater, as you actually said, is only picking signals and then broadcast them. I mean, just repeat them. Repeaters do not do much with signals when they are working. They are just there to repeat the signals, just to boost them, let them keep going. Okay, but bridges go beyond that one. Bridges do processing. They process. Now, by processing, what it means is that look, before even signals get in, to the network, let's say, for example, before even leave this particular network, which I'm operating with, the server point, or to the point where there could be some processing happening. there are some checks that bridges are able to do. Bridges are able to do a lot of checks, which be a matter of I think I'm have a call here. Let me just quickly cut this call in. Okay, I'm supposed to have a meeting at 3 o'clock, but okay, that what happens. So it can travel. The electric bridge can connect the devices over long distances, but then the maximum actual distance it will cover also depend on the type of cabling, the transmission mediums you are using, not just on the bridge itself, but then the very ones you may be using. Okay, so it can carry a distance as well as the type of processing it can be involved in. Switches, repeaters are limited. They don't do much processing. They are only passing it on. Keep going, keep going. Yeah, but for bridges, since bridges are carrying a whole network to a server room, they are able to do management of that network with respect to what is going out of the network and what is coming into that particular branch of the network. They do more, even to the extent of security staffs. But repeaters are just, let me just add more power to it. Let me just forward it to go. Is that okay, Nomad?
Yeah, well understood, sir.
Okay.
Thank you, sir.
You're welcome.
Okay, sir.
Welcome. So these are the things that these guys, these devices will have to do. That makes them what they are. Okay, Joseph.
Yeah, I want you to clarify something for me.
Okay.
Like installation of multi TV, you know, we have where the plate is being kept and it usually faces a specific direction.
Okay.
Does the bridges serve work like the same way? Though the plate might, the L and B might not necessarily be a bridge, but is that how they also serve?
That's the principle in mind. In terms of principle, they are in the same line. That's in terms of principle. In fact, all these devices are working with the similar principle. You as rightly said, the DSTV, the multi-TV staffs, you must turn the dishes until it meets in line of sight with a satellite up there before they can begin to communicate. In principle, that is what they're doing. It's just that the activity may differ, but in principle, the same thing is happening.
Okay, thank you,
I
sir.
get to me. You're welcome. You're welcome. Okay. That's what really happens. In principle, it's the same concept at work. But then as far as the main activity is concerned, they're different. That's what connection is about. Okay. So these are the devices. We've seen the router, we've seen the bridge, we've seen the switch, we've seen the hub. Now the modem. Modem is somehow similar to what will be done by some other devices. Now, what is the purpose of its modem? The modem, in fact, usually the modem has a full meaning as modulation, demodulation. That's why it's the name modem. So it's just a part of the modulation, MO, and a part of the demodulation, DEM. Now, why modulation and the vice versa of demodulation? Modems are used in an environment where the nature of the signals being transmitted are different. So when I talk of different signals, I know by the third year, you've already known the type of signals which travel. It's either a digital one or it's an analog one. That's what really happens on the internet. It's either a digital transmission or an analog transmission. Now, if it is digital, then it means that that is the packet which is coming from a real machine, a computer, a PC. Now, if it is analog, that is what is likely to happen on a telephony network. And most often, the various networks, the backbone network which carries our data are in the form of telephony. The packets transmitted are in the form of analog. But then the PCs which we use to transmit data, which will then have to travel over a network of that nature, of analog nature, are of a digital nature as well. So by the time that signal gets to the point of the gets to the point of the telephony backbone network, it would be in the form of digital. But digital network data cannot be handled by an analog system. Not possible. So what happens? There will be the need for a device in between the PC, which is transmitting, and the telephony network, which is carrying the transmission. There must be a device which will modulate the digital data into an analog format so that it can travel over the telephony network. But then you are sending the data to a telephone, a different PC somewhere. Now, by the time it is arriving at the PC, because it's being carried by the telephone network, it will be in the form of analog by then. So you will need, once again, a different device that will now demodulate what was modulated. That is taking it back to the original form. And then that is from analog to digital, so that the machine the PC can now pick that data in the form of digital again. That is the nature of what modem does. And it's only trying to ensure that devices of different signal nature can still communicate. If not, it will be a very difficult task to enable communication between devices or systems that are carrying different types of data. For example, we can think of, yes, we've already said telephone lines. Telephone systems are using analog. That's what they do. So that it's the signals travel in continuous steps. It is continuous, like a wave. That's how they travel. But digital ones, they do in discrete steps, 1, 2, 3, 4, 5. While the continuous maybe 1, 1.2, 1.2, 1.3, 1.4, then it carries on. So it's that in that wave type of signal nature, while the discrete is in that sharp-edged whatever, that shape. So the two cannot communicate directly with each other, but then it is rather allowing the two to communicate, even when it seems impossible. That's exactly what how do you call it, the modem is supposed to be doing with the network. Okay, then we have the repeater, as you rightly said. In fact, for repeaters, I think it's already been said somehow by one of your colleagues. What is the repeater there to do? It is only to ensure that whatever has been transmitted at a point in time, it may begin to get weak. Let me use this as an example. I think I've already started an example. These communication systems, MTN, Vodafone, and the rest, they have different masts set up at different places. Now, every mast has drums. Those huge drums, I call drums, those huge drums which are positioned on the masts, those drums, they're not there for just any reason. No. They are there for a particular reason, for a good reason. And the reason here is that they are the very ones which are receiving the signal from different points. So that's why they've been positioned not just anyhow. They are not just placed on the masts anyhow, but they have been positioned with respect to the various places where those masts are located. They know them, they install them, and they know what they are doing. So what are they there to do? I make a call, or you make a call from a point. You see, anytime you're making a call, if you're not very close to a mast, it's hard to get your call through, because it is the masts that will pick the signals and then transmit them. So if you aren't close to a mast, it's so hard to get your call through to the other person who must receive it. Very hard. That's why you find people climbing mountains and jumping over the sea and the rest just to get signals at work. Okay? Now, what happens here is that he will send the message, or he will send the signal, that I want to make a call with this particular person. Then the closest mast will pick that signal quickly. Now, in the attempt of getting to the switching point, you see, anytime we make a call, there must be a switching system service that must switch, that must work around, process that particular call before the receiver will get it. But all this is done in real time. It is not done. I mean, that's why sometimes even before you even get the call ringing, it will take a little time. So it must get to a switching room, which maybe is Accra or Kumasi or even somewhere else. But the place where you are located is not close to that switching room. So what do you have to do? The masts which have been mounted at different places must be carrying the messages one from the other, until the receiving end gets it. Now, why one from the other? Because even for signals, when they travel a particular distance, they begin to grow weak. Because the term for that weakness is called attenuation. ATTENUATION. They begin to grow weak. Now, when the weakness comes in and there is no close by mast, that call will drop. You won't get it. The call will just stop. As if the call has been cut. You just stop. Because it could not reach a particular mast close by that could add more strength to the signal and boost it in travel. So they are just there to make sure that as far as the signals are traveling to the switching room, at every point of a mast, there must be a receiving signal. That signal that would have been weak by then will be boosted in strength, and then it will flow it over. Just like this racing system we have, this baton changes, which we have in our athletic system. Okay, you run and run and run. When you are getting tired, there will be someone else in front that will be taking the stick. Then you give it to the person. Now the person will pick it with fresh blood, fresh strength. So the speed at which that person can go will be better than what you were going. Now that person too, they are all trying to end at a point. By the time he also gets to a particular point, he begins to grow weak. Someone there will be there to pick the stick. Then he'll pick it and then add more strength. Then shim, he goes. Until the reaching point is you get to the reaching point. That is the nature of what repeaters do. Repeaters are just there to amplify the signal that may be growing weak in the transmission process. Yes. In fact, a switch can serve the purpose of a repeater, but not vice versa. So switches are somehow signals boosted as well, but repeaters are made for that purpose. That's what they were actually made for. So that is what a switch is actually used to do. Okay. Now for a gateway, we are just connecting two or more different networks and allow the communication to happen. Okay, with whatever the protocols work. So a gateway is that particular network device which is connecting the different networks and enable the translation of data between them so they can communicate. So a gateway can fully be a full machine at work. It is only responsible for ensuring that it is only allowing your company to connect to the internet. That's what we call the gateway. So when the internet is coming in or someone is coming from the internet to your network, it is the gateway, the door, which will allow it. Okay. Now, if it's going out to the same thing at work, mostly a default gateway may be a router. Okay. A default gateway may actually be a router because it's responsible for forwarding those requests coming from within and from without to make sure that it is actually so view it as a machine which is now connected to the internet, allowing others to go through it to the internet as well. And internet coming in, that is what we call the gateway. Very, very important as well. Then the cables. I think we are left with cables. The cables. Is the hand up? Richard, your hand's up.
Yes, please.
Okay.
So, sir, please, how do you differentiate between the gateway and then the server?
Okay. In some instances, okay, as I've already said, in some instances, they could happen in the same system. But then, if we are considering the gateway as a default system, as a default router or as a router, then we are looking at the connection of the server to the router. You know, routers are connected to the servers. That's what is happening. So usually, you see, in a typical sense of the term, it is not, they aren't working in separation. They are working together. A router is managed by a server. So consequently, if I'm working with a browser, I'm working with a router, I'm working with a machine that is managing a router. So it's a machine, it's a full server on its own. Okay, so a gateway is actually a server, but we cannot have that as the only server. Okay, you may have other servers. You may have a web server. You may have a print server. You may have a database server. You may have application servers and all of that. So a server is not just one thing as a gateway. A gateway is behaving as a server. Okay, but it is not the only server. As that one is allowing for internet connection with the router, the main servers are the ones that are processing different requests like website demand, application demand, and the rest. Those ones are the ones that are doing that. Now, this one is a server as one, which is serving the whole network with internet connectivity in that sense, but not like the web servers. Is that clear?
Yes, sir.
Okay. All right. Now, Eric, stand up. Okay, I think let me.
Yes, sir.
Okay, Eric. Yeah.
Hello, sir.
Yeah.
Please, I want to ask, at what point does the repeater detect that at this point in time the signal is weak, so I have to boost it? Or is it automatically done, or is a manual something that someone will detect that at this point in time the signal might be weak, so I have to boost it? Please, how does it work?
Okay, thank you. Okay, so let me pick the wired structure first. Okay. A network administrator who is setting up a network should know that at this length of this cable, let me position a repeater here and connect to it. In fact, a repeater, let me show you a picture of a repeater. Maybe you will understand better. A repeater's image. Let me come in. Okay, this will be fine. This will help. Okay. See this image of a repeater? Come in. Okay. Here's an image of a repeater. Okay, I'm coming. Let me. There was one. Okay, so maybe this will complement it. That's a complement. Good. So see what's on the screen now. Here's a repeater having two ports here. Now, one port is receiving the signal that are coming in, say from this one, the weak signal. And this one is the one that is going to amplify the signal onward. So it takes you, the network administrator, to know where to position this device here. You must know where to position it, because you have come to know that in the case of a network administrator, you should know that at a point in time, signals begin to go weak. Because you see, the point is, you can't just position it anywhere and expect that the device can go and see that what else is there to know that this signal is going weak. Let me go and help him. No, you know that I'm using a cable to connect to this particular switch. Now, if the switch is far away from where I am, it can't directly connect to the switch because it will now be too long for it, for the signals that are traveling in it. So in between them, I must install a repeater in there that will pick the signal coming in. So it's a device. It's a device. This one is a full device, which we position somewhere in the network. Like when you are walking around in a company, an institution, or a school, and you'll be seeing these Wi-Fi devices all over the place. On buildings, you see them. Here, you see them. This is exactly where they're also doing. So they're positioned at critical points where we know that at this point, there may be a possibility of signals going weak. So in order for me to keep boosting my signals, let me place it there. Now I'll connect the cable which is coming. The one going to the switch. See, let me just say it this way. The switch is somewhere here. The switch somewhere here. But it can't travel from here, this machine, straight to the switch here. It can't. Because by the time it gets here, the signal is going weak already. What is coming from here? It gets here, it is too long for it in the cable. So it will begin to go weak. And it can drop. In that state, because I am traveling to this place, the network administrator, I will position a repeater here. That will now pick what is coming from here. Now it will amplify it within this one and will continue to send it to the point where it must go to. So it's a device you position at the right place to ensure the proper transmission, not generally. So if it's wireless systems too, now, you see, the question I was going to ask you is, why do we even still have calls dropping? If it will be an automatic way of getting to know that, okay, this one here, you must quickly go and help him because he's getting weak. Then why do we even still have calls, people traveling or climbing trees, climbing mountains, just to make sure their calls are going through? Even then, they still haven't dropping. No. So if you go to the village, some villages, those rural areas where you don't have enough of these masts, before you can call your friend or your colleague, you must walk all the way from where you are, get to a place nearby, which may be having the mast located, before you can make a call. If not, you can't make a call. You can't make a call if not that one. You can't make a call. Okay, so it is critically or strategically positioned to ensure that particular transmission is carried out without any blockages. I hope it's clear.
Yes, sir.
Okay. Thank you. All right. So that is what these devices are actually doing. So, but I left the cable. Okay, Richard, right?
Yes, please.
Okay.
Sir, I beg one question or two.
Okay.
Is it possible to have a mask and still have a weak network? That is one. Then the second one is you were saying those big drums, are they the same as the bridge or they are repeaters?
Okay, that's fine. Okay, so let me just put this way. You can get masts located and still get networks flopping. You see that you see them every day, only because the distance between you and that mast may be too long that by the time it gets there, it's getting weak. So you must go and climb mountains to get closer. Okay, the masts may be there, but it's not too close to you. Now, if the masts are very close to you, then the likelihood to experience those challenges may not come from you, but the MTN's technical places. Maybe there's faulty systems in there or some things are not going well. No, fine. But then as far as they are close to you in this range that they must be, then obviously you will have to experience a good network, a good transmission of data. Then you can get it through. Yeah, that's for the mast, what they do. Now, those drums which are located on those masts are repeaters. They're the things enabling the repetition of the signal onward. Let me tell you one thing. You can't place those masts there and then only place repeaters on it. If there's a need for a company to locate their bridges on those masts, they can get it on board as well, because it is an advantage. You can kill 2 birds, 3 birds, 5 birds with just one stand. Then you can just get in there. So not, you see, sometimes even it's not a mast, it may be just a normal pole, which you see, also colored red and white, but not a mast on its own, which may be having bridges of companies in there. Okay, now some companies equally get into some of these masts, into an agreement with the companies, and they locate their bridges on because they think it's a good position for them to also make use of. Yeah, but mostly for the masts that are in the care of the telecommunications, they are actually in repeaters. They are repeaters, actually. I mean, they are repeaters. That's what they are there for. Yeah. Okay. Now let's look at the cables quickly. The cables, also very important. You know, it is the cables that allow proper transmission. You see, maybe I was going to ask you a question. I feel like a question asking, but the question then comes like, in the case of transmitting data by cabled means or doing by wireless means, which is more effective? Well, that's the question I will leave for a different day. We'll get there. But the cabling, or let's say the transmission, is done in a cabling. And mind you, when signals are generated from a PC and they are traveling through a signal and a cable to a destination point, they take different forms. Let me give you an example. When these are traveling, whether it is cabled or in the cyber highway, or let's say the wireless, sometimes when there was a heavy downpour of rains, it has an influence on the signals, especially when it comes along with thunders and lightnings. They strike and there's trouble. Even electric power also gets experienced with some of these things. It can happen. So the signals which may be passing through the cables sometimes will have to be found in a different format. But we call it line coding. It's a network coding thing. We will get there actually. But just to give you an overview of what that is when it comes to cabling. It could be a different way. Then they will travel in the cable. That means that whatever is generated from the computer is called data. Now, when it reaches the signal and begins to go through when it reaches the cable and begins to go through the cable, data is changed into signals. How do we even get signals that are strong enough to resist any obstruction in the environment? Now, as I said, that would be a talk of a different time when we would be able to generate, as a network administrator, we must be able to generate in a particular format signals which are good enough to resist even external interferences like those noises, like crosstalk and guys. Even in the cyber highway. For example, let me give an example. Sometimes you find yourself in your church, your pastor will be preaching in the church, and then there's another church nearby also using their amplifiers. But then, because they have strong signal strength, the speakers in the amplifier in your church may go and pick the signal in the other church. Then the preacher who is preaching will not be your pastor, you'll be hearing in the amplifier, but that one you'll be hearing. It happens, we call it crosstalk. It's all because of the way the signals have been structured to travel in the cable. Very, very important. Now, for this reason, cables come in 3 types. There's a cable that we call the coaxial cable. Coaxial, C-O-A-X-I-A-L cable. Let me give you an image, quickly get an image of the coaxial cable and why we even call it a coaxial cable. Coaxial cable. Images, give an image of that. Okay, so there's the coaxial cable. Okay, let me show you something over here. Okay. It's a coaxial cable. This is how they appear like. Okay. And then you see, remember, let me show you Let me just show you this one to help understand it. Coaxial cable network. So, okay. Okay. Show you this one as well. Okay, this will be fine. Okay. Okay. So look at this two. Let me put this one to here. Now, as I was talking about the coaxial cable, you'll be thinking, where is it positioned to enable connection? Internet. This is the typical nature of the cable. Some of the cables that are used for a DSTV dish or the multi-TV device. That thing. That is what connects them to enable transmission. Now, this is that copper type, the coaxial cable, and that is what was being used in those times. Okay. Now, most often these ones are also used as backbones, a direct connection from a satellite or something to your router to enable connection directly. So this is a way. So you realize that this is a network cable and adapter. Okay. Now this is the coaxial cables ports. What else you may have? Sorry, the other ports like the RJ45. There's a port here, and this one is the other one. So this was a real way by which we were connecting internet directly to a system, and it was by this particular cable called the coaxial cable. Okay, the coaxial cable, and they are very, very powerful and with much strength. Okay, then we had the twisted pair. The twisted pair. Let me show an example of that, an image of that too. Twisted pair cable, which has become the most commonly used cable for networking today. Come in. Okay. What we are using today. Okay. Okay. So what we are using today mostly is the twisted pair, this one. Okay. And they have this RJ45 connector at the tip. Here's the RJ45 connector, which one end connects to the device and the other end connects to the switch, like this one. That's an example of how it's connected. So the other end is connected to this particular thing, and the other end is to the machine, so that they can enable communication between the two. And that's how the RJ45 are done. Now, these devices or these cables may come in two types. We have the ones which are shielded. Let me get an image for you to see that one too. Those which are shielded and those which are not shielded. Now, those which are shielded, it's done just because they want to control the level of interferences that could affect the signals. You know, when these signals are traveling, let me show you an image here. But these ones, they're just smaller cables which are coming together to enable connection. So look at this one. Now, there's a shield, something. You could see a shield here around it. You could see a pure shield around it. Something like this shield around it like that. Now, those shields are there just to ensure that some external interferences will be under control on the cable's signals. Okay, so I earlier gave an example, like sometimes even a lightning strike can cause signals that are traveling in this particular cable to be distorted. It can create distortion on the signals which are traveling. But then when you have these shields that are placed in there, it really helps to bring such under control. It controls it, or it minimizes the impact of any noise or distortion that could interrupt the signals that are traveling. That's what makes them also much more powerful. Okay, that's what makes them very powerful. Then, as I said, it is working with the RJ45 connector. That tip. Where is the one I didn't tell you? Let me go somewhere here. Oh, I deleted it. I deleted it. Let me show you the RJ45 connector. Those RJ45 connectors, sometimes some of them come in smaller sizes, which are used for the telephone connection, telephone lines. Okay, so that one becomes. So let me just show you this image quickly. Okay. Okay. Okay, this is the RJ45 connector. So that's what is found at the tip here. Okay, what is found here on this side is connecting into the this thing, the particular one. What is happening? You may have some that come in smaller sizes, and that one they are for telephone lines. That's what they are also used for. The last type of cable is what we call the fiber optics, or the fiber optic. That's the last type of cable. Fiber optic cables are currently the fastest and the most powerful when it comes to transmission of signals. Why? Because they transmit signals with the speed of light. Very fast. Very, very fast. They do it with the speed of light. That's what we call the fiber optics. That's how they are. Okay? And most often, they are also used as backbones. In fact, they are most often used as backbone. When I say backbone, it's more like connecting a whole network to a different network. Let's say for segmentation, we'll get to that too. Segmentation is like breaking your big network into small networks, while they all behave as networks. Okay, on their own, you are breaking your huge network into smaller networks. Now, each smaller network is behaving like an isolated network on its own. Then you connect them all with backbones, making it faster. It's a technology which makes networks fast and more secured. Instead, we would get there. So look at this one. So we have these ones here. These are the fiber optics. The fiber optics cables. These ones here are the fiber optic cables. Yes, very, very, very powerful. Now, these may be the ones serving as bringing the network in here. Then we have the RJ45 connected the total pairs that will also just distribute the network, the internet to the other machines. Okay, but that's the nature of the cables. So the fiber optics, the coaxial cable, and then we have the twisted pair. These are the ones which are used for networking. Now, basically, for a local area network, we don't usually use fiber optics for a local area network, but they are mostly used for backbones or to serve as connections between strong, huge networks, because they carry data in a very fast mode and also very powerful. Okay, so I hand up right now.
Yes, sir.
Yeah.
So the three cables that you've talked about, which ones are used for that of the network mast, these telecommunication companies? Because we know they lay cables underground, then later on they mount them on these telecommunication masts. So these cables, which of these three falls under?
Okay. So, but
are used.
Okay. I'm listening.
Among the three cables that you've mentioned, I want to know the cables that are laid underground for these telecommunication companies. Their mast.
Okay. Okay. Now it's much more obvious. Okay, much obvious. Know exactly the network device we're talking about here, as like the towers or the masts which we see. The truth is, several types of cables can be used. Any type of can be used. Now, depending on the type of equipment or the machines which are at work. Okay, for example, if you are connecting, let me just say, these microwave radio antennas, okay, that are carrying these radio level of frequencies. Now, most often, these are used, they use the coaxial cable. They use the coaxial cable. So what that means that, as you rightly said, on the mast itself, connecting those equipment to the antennas, that is that base, you may have a base of the mast where you will find some cables running up and down on the mast, connecting the antennas, the radio equipment to the antennas. Those ones are the coaxial cable we are talking about. But to connect, transmit data from the mast itself to the network itself, you would need a high-speed system which can travel over a long distance. And that's obviously the case of a fiber optic. You can't be taking off a coaxial cable there. You will need a fiber optic. Okay, that is what will do a much more better work. So for even the grounding, okay, like the earth and something like when they're grounded, where you are placing cables within the earth, okay, most of those cables which are done are made of copper. You know, that's that type of system, okay. But the main cables used on these telecommunication masts, I'll be very frank with you, the coaxial cables, the fiber optic cables, depending on the connection you are doing. If it's a connection on the mast itself to the antennas itself, then you're using a coaxial cable. But then if you're thinking of transmission from mast to mast, we are thinking of fiber optic cables before the power starts maybe coming.
Okay, sir. Thank you, sir.
Exactly. You're welcome. All right. Okay, so these are the things we've been talking about all this while. We want to establish a good connection on our Ethernet or on our network systems. How do we make sure we have put things right, or things are well positioned for a proper and effective communication of our networks? Very critical, very important as well. Now, when you have set up all of these, how do you enable these to communicate? You've done the setup though, yes, of course, you've been able to set up all of these. You've positioned the devices all right. You've connected the cables all right. All of them have been done all right. But how will the devices or the machines which have been done in that manner, how would they be able to communicate among themselves? Very important. Which means that when you've established devices on your network, the next you have to think of is, how do I identify these devices? The devices which have been put in place must be identified. Now, that's the only way by which you can communicate with them. If not, you can't do any proper communication with the devices. They must be identified. They must be known so that you can identify and then send them, whether it's a printer, a phone you're connecting to it, it's the server, your own PC, your own laptop, whatever. You must be able, the network must be able to identify those devices which are on the network. Now, that unique identifier, which is assigned to a particular device on a network, is called the Internet Protocol address, the IP address. It is called the IP address. The IP address is responsible for ensuring that every device that is found on the network is duly identified, or it has an address. Okay? It is just like the way our postings are done, or even human names are done. Everyone that comes to this earth has a name. That name is unique to you. And that is how you can be contacted, or something can be delivered to you. So the IP address is now identifying the device on the network. Now, it can also help to know which network you belong to. The IP address is very powerful to tell it to know which network you belong to, and then it will enable communication between the two machines. Now, these IP addresses come in different types. Usually, we know now we are using the IP version 4. We are not yet with the version 6. We're still with the IP version 4. Okay. Now, for the IP version 4, it comes in a 32-bit address. 32-bit address. When I say 32-bit address, it means that the 01010101s up to the 32nd bits. Okay, and they are usually written in what you call a dotted decimal notation. But then when you convert them to decimal, then you will get into 4 octets. So, like for example, you have 192.168.10.9. Now, this is a typical IP address, which of course, when you convert this to binary digit, like the bits, you have 8 bits plus 8 bit 16 plus 8 bits 24 plus 8 bits 32. So we say it is a 32-bit address. But then when we convert it to this, that becomes more human readable, because no one will have to memorize into his head 01s. So for the 192 alone, you may have 001111 blah blah 0. Then that once it will come 32-bit set of bits for every IP address. No, that's why it is put into this octet. The 4 digital values, which are now separated by dots. That is what the IP address stands for. That's how we assign it. So we assign it to the machine. We assign it to a particular device so that it can work. Now, if there is no IP address on a particular device, then it cannot be part of the network. If you don't have it on the device, then the device cannot be part of a network. Of course, we will discuss what we call a PIPA. We'll discuss it later on. But that is what happens if there is no IP address. So there is no way you can communicate with a particular device. Now, there are 2 ways by which we assign IP addresses. 2. We do it in 2 ways. Now, it's either by automatic means, okay, by automatic means, or by manual means. It's either automatic or it is manual. Now, depending on what you want. Now, if it is manual, then it means that you, the network administrator, must move from a machine to other machines and set the IP address on the machine yourself. That's what you must do. Let me check this out and see. That's what you must do. So you move from one machine to other machines and then set the IP address there yourself. You must set it. So you must be the one who will now allocate it in there. Now, if not, the machine cannot have an IP address or cannot have that value, that number. Okay, as I said, we are using the IP version 6. So, since it is of that nature, you must assign it accordingly as the way it must be done. Now, if not, as I said earlier, you will have challenges. So look at what is on my screen now. I had to go to the network area, and then these are my connections on my computer. Okay, now the connections are of a number of type because of one, then the wireless, and then the virtual box, which is also making use of some of the network resources there. So, for example, I have here, this is my network at work. So I go check the properties, then I'm using the version 4 of IP address, then I go to properties and see. Now look at this one. It is either I obtain an IP address automatically, or I use a particular one that I will enter myself. So if I say use the following IP address, it means I must be the one who will enter it here, 192.168, then maybe 102, then 22. Then I have come to assign it here myself. That means that for every machine in the company, even if they are 1,000 in number, you must move from one computer to a different computer and assign the IP address in there yourself. That'll be tedious, isn't it? But that's what you must do. But if it is automatic, then it means that all those IP addresses, maybe plenty of them, which you must assign to the computers in the company, you have assigned them all or placed them all in a server, whereby the moment you connect to the network, it will now deliver an IP address and give it to you. That means that the moment you connect to the network, the network itself randomly will select one of the IP addresses which are not active at that time, and it will assign it to your computer. Now, by then, you would have obtained an IP address automatically. So you can see, you can't enter anything here. It won't even allow you to enter because the machine, the moment you connect it to the internet or to your school's Wi-Fi, it will now request for an IP address from the server, and the server itself automatically will assign one to the server. That server, to your PC, sorry. That server, which is responsible for delivering IP addresses automatically to machines within a network, is called the DHCP server. Dynamic Host Configuration Protocol server. So it will have a pool of the IP addresses, a pool of them, plenty of them. The moment you connect to it, the system, your machine will request for an IP address from the server, DHCP server. The DHCP server will also respond. So that sometimes when you do that, you might see on your machine requesting for IP address. On your phone, whether phone or PC, you see that it will be just there requesting for IP. Maybe when you connect to your Wi-Fi, when you put on your Wi-Fi device, your Wi-Fi function, then you see requesting for an IP address or obtaining an IP address. That means that it's now picking an IP address from DHCP server so it can use. Well, of course, it's obvious to know that when this happens, it is so easy to manage your network because you don't need to be going around from machine to other machines just in the name of going to find or assign an IP address. It gets things work even better. But the question is, you are as a network administrator and a consultant as such, which one do you think will be much more effective in the management of a network? If I ask you that, what will you answer? Which of these two, manual or automatic, which of these two do you think will be much more effective, or security and other stuff wise, which one do you think will be more effective in the management of a network? Okay, Christian.
So please, I think the manual one.
Okay, why? You can tell me why.
The automatic one will easily be leaked or be hacked. Because it is open. Any hacker can easily fish through it and then get more information about the machines. But if it is manually put or keyed, I think it will be a little bit okay to be used. Thank you.
Okay, but how will it be easily leaked? Is it because
please come again, sir.
Is it because the server, the DHCP server on which it is located, is not well protected or something?
Sometimes some automatic things are mostly leaked.
Yes. Easily, okay.
Yes.
Okay. Because it's the nature or the way by which it will be assigned, it will be very easy to get it leaked or leak some of these. I understand you. Any other? Okay, any other? He thinks manual is back. Okay. Can go ahead. Who's
Okay, sir.
uh-huh.
I also think the manual will be better than the automatic,
Okay.
because you see, with the first part of the IP address determine the server which you are on.
Okay. The first what?
As in the first
3.
the first 3 part of the IP address.
Okay. Please, a minute. Excuse me. A minute. Let's pick the phone and I'll get back to you in a minute, please.
All right.
Okay, thank you. Sorry, I'm so sorry. Eric, you can go ahead. Who was speaking before I left?
So please, I was.
Yeah, that can please go ahead.
Okay, so what I was saying is that with the network ID of the IP address, when it's automatic, that is anyone that gets on that network can guess the network you are on.
Okay.
That is, they can get the remaining, which is the host part of it.
Okay.
But with the manual, outsider cannot get access to the network parts on which you are on. That is why I'm saying that the manual will be better than the automatic.
Okay. But mind you, the network parts of an IP address is not fixed. It depends on the IP address you are using. It should be the first 3. Can it be the first on the first one? Can be the first 2. Then that become better. But then it's general. Okay, well, as you have said also, okay, there's a point there. Thank you. Any other? Any other? Okay. All right. So basically, it seems like we are all going in for the manual somehow, because we feel like that is much more safer than the automatic. Someone said anything automatic sometimes poses much more challenges than things which are manual. Like the automatic car just poses much more challenges than a manual car. But that's a different concept though. But you see, I agree with you with the manual. But in the case you may have a very huge company with about 1,000 workers and they keep increasing every day. Well, the very first time of setting up will not be easy. But when you are set up to, others joining in will not be that tedious, because you're just going in for one person who have been employed, 2, 3 who will be employed, and you assign it for them and then you go. That's fine. Now, automatic 2, sometimes, you see, the trend here is that sometimes if I come to the Wi-Fi or I join the Wi-Fi, and then my machine requests for an IP address from the server, and the server assigns the IP address to me, I will use the IP address as far as I still remain on the network at that time. That will be with me until I get off the Wi-Fi. Now, when I get off the Wi-Fi, that IP address will still remain in the server. Someone may come in maybe about 2 days or even 2 hours later on to join the Wi-Fi, and that same IP address can possibly be given to that same to that person. So in practical, what has been a particular sort of challenge is that if I, who may use it as the first time, may commit crime with that IP address, and later I leave, I hacked on the IP on machines with that IP address. Then I later leave and go. Now, the time that it was known that there's trouble on the network and that administrators have identified this IP address to have done this problem, by then, someone else may be using it. The question will go like, who will be held responsible? The one who has come and left, or the one who is currently using it? It will be hard to know. But then the good news is that there are always audit trails and files which are keeping records, the log files, which are keeping records of everything. So today, most often, it is two things in mind: what you call the physical address and the logical. So your computer's own firmware address, that MAC address on your machine, plus the particular logical IP address which was assigned to you. Both of them must be kept in the log file to ensure proper identification of who came here. Okay, but even then, the question is, the guy is gone. Okay, so security-wise and the other staffs, manual things will do a better job. But of course, for the automatic staff too, there are better measures put in place to ensure a much more proper security in the transmission. So not just that a matter of just putting it to bear, but then there has been a proper way as where these things are also placed in a position where they are well protected, or things are done in a better way than maybe before. But in all cases, as you said, there's no single particular way of saying this is better off than the other. It depends on the company. If it's a company with a small sized company, not too huge, manual will still do a better job. But a very huge company may have challenges with having to assign to everyone manually. That will be a little bit of a challenge to the machines. But in all that's said and done, both are used in the right, in the way they must be used. Okay. Now, as was said by one of you, these IP addresses, whether it's automatic or manually assigned, they have a structure. Now, the structure has it that the IP address should be able to help you identify the network and the machine the network is part of. That's the basic thing here. The IP address must be able to allow you to know this is the network the IP address or the machine is part of before you are able to locate the machine itself. Two things. That means that every IP address has two parts. The first part will lead you to the network. The second part will lead you to your own device. That's why for MTN and the other guys, you may have 024555666. Then another one, 024666777. Then 024777888. Why? The 024 will lead you to know the network, and the others will be the unique identifier for your machine. That's the nature of how networks are operated. So every IP address somehow must also have two parts. One part which will enable you to know the network, and the other part for the machine on which the network, the network, the machine which is part of the network, its unique identifier. Two parts. But in knowing the two parts, there are two ways to know the two parts of the IP addresses. One, we use what we call classes. And two, we have what we call subnet masks. Now, these are the two main ways by which we can use to know which part of the IP address belongs to the network, and which one belongs to the host. Now, like 024, I earlier gave 024555666. Now, this part is the network part, and this part here is the host part. That means that the device on which it is found on. So you could see that the network part, almost all the devices in that network will have the same network part, whilst the very part which is for the host will keep changing, because the network is the same, but the hosts are, or the devices or the hosts are different. So in classifying it, let's pick the classes. The subnet mask will lead us to something else called segmentation. So that one we'll do today. But then let's deal with the classes. In IP addresses, there are 5 different classes. We have the class A, the class B, the class C, the class D, and the class E. 5 of them. Now, look at this carefully. If it is a class A IP address, if it is a class A IP address, then what it means is that the first octet here, the very first octets, the 192, or sorry, in this case, please, let me correct this. In this case, 192, it is not right because it may not be in the same response. So let me just do this way. 10. I think that will fall in line well for me. Now, it means that the first octet here must be in a particular range. The range of from 1 to 1 to 6. So any IP address which you see, and the first one is within the range of from 1 to 126, you can boldly say it is a class A IP address. Of course, today I do what you call a classless interdomain routing. So we don't even target the class anymore, but still, it is still there. I'll explain at the right time. So if it is there, so you could see 10 here. That's why when it was 198, I had to force myself to change it to 10, because that would not make sense with the example I'm making. That's why I had to change from 198 to, from 192 to something within the range of 1 to 126. Then it makes sense now. So we can see that this IP address here is a class A IP address. It is only the first octet we observe. Just the first octet we are observing here, not this second octet or third or the fourth. The first one. The first one must be in the range of 1 to 126. Noted? Then for class B, it must be in the range of 128 to 191. That's class B. Then for class C, it must be in the range of 192 to 223. Now, these 3 IP addresses are the ones which are used for networks. The last 2 here are for different purposes. In fact, class D is for the purpose of multicasting. That's from 224 down to 239. We don't use it in a normal network. It is usually used for a special purpose called multicasting. Then the last one, which is the class E, is from 240, where it ended, down to 255. And this one too here is not used in networks. It is for the purpose of experimentation. It is used for experimentation So these two IP addresses are not usable in networks, but they are available for a different reason and purpose. Okay, your hand is up. And Zani, Darko Prince.
Sir, please, what of 127?
Okay, that's a good question to be asked. Now, the IP address 127 is actually a special IP address used for what we call loop backing. Let me explain from this side. So the IP address itself is in the form of 127.0.0.1. This IP address. Let me ask, have you done web development, website development? Have you done it?
No, please.
You haven't done web development. Haven't you done anything where you had to host maybe a site in a local server, like the WAMP server, the exam server, locally? None has been done? Okay.
No, sir.
Okay, all right.
Yeah.
All right, okay. But
No,
then,
no, sir.
this IP address here called 127.0.0.1, it is a special IP address which is used to test your local network's stack. That means that I am checking to see if my network stack or my network architecture is responding to a network, or it can join a network. So I do what we call, I use it to test my network, loop backing for testing. Then if there's a response after a test, then it means that my network stack is working. That is to say, my network interface card, I test it. So typically we use the command ping, P-I-N-G 127.0.0.1. I am doing a self-test on my network interface card. We call it loop backing. The term loop backing. This. So it's a special one. So for example, let's say if I have this here in my CMD command prompt, okay, and I do a ping of a 127.0.1, then I enter. Look, I'm getting replies. It means my network interface card is working properly because I pinged it. Here's the pinging. But if I ping this one, 192.168.10.2, see what is happening now. It can't locate that network interface card, so the request is timed out. So it's not coming. But this one gave me a reply from this. But this is giving me a request timed out because it is not locating any IP address in that existence. Now, because I had this reply of, it means my network interface card is operational and it's working well. It's called a self-check or self-test. That is why the 127 is a reserved IP address. So we don't actually add it to these ranges. I believe it's clear. Okay.
Yes.
That's the purpose of the, so we don't actually add it to those ranges when we're trying to classify IP addresses. Okay, good. Now, have a note.
Hello, sir.
Yes.
Sir, please, where exactly did you go
the black screen
before having access to,
Yeah.
testing the net?
Let me just, I use the command prompt. So I just went into the search here and I typed CMD like that. Then I entered. Then the command prompt came. And I typed ping. Yeah, ping is a tool for doing the testing, checking. So I then ping 127.0.0.1. Then I entered and it gives me replies. So you, as a network administrator, sometimes when someone, okay, welcome. When someone complains to you, maybe you are the administrator of the network, When someone complains to you that, oh, I can't browse with my network, you can even use that same ping to, you can ask him, okay, what's your IP address? If he tells you the IP address, you can use the same command ping to check, to connect to his, using the ICMP protocol, to connect to his, to ensure that it is really working or not. That's why I did first ping 192. Let's say someone has come to complain, and I'm checking his own. If I use the 127, I am checking my own self. But the same ping can be used to check other people's own, like 192.10.10.4. I do this. It will not connect because on this network right now, there is no IP address with this, so it can't connect now. Now, if it connects successfully, you must have reply from. That one, it means there has been a connection effectively. That's what really happens. So the 127 here, at least I am sure and certain that my network interface card is operating well. Of course, if it's not operating, then how would I even be having this lecture with you online? I mean, it's not possible. But I just wanted to demonstrate it for you to see how it really works. So that's how to get to the command prompt. If you are using Linux, the same thing happens. The same thing happens. Don't want it to be in the terminal. Okay. But let me even tell you quickly. In this course, the later part, we'll be doing some few Linux commands there, which will be used for networking. Yeah. How do I issue commands to manage my network? We'll deal with that few stuff of that before we're through. Okay. So these are the classes: Class A, Class B, and Class C, which are now known. So the last two here are not things we need for the class. Okay, so let me now give you an example. If I have this IP address 194.20.26.30, this IP address, what class is it in?
Class C.
Class what?
C.
Class C.
Class C.
Class C. This IP address is a typical Class C IP address. Typical one. Very important. So that's how it works. So having known this, then you can now identify which part of the IP address belongs to the network and which part of the IP. Yes.
Please, I beg you, if you can go back, the D and E.
Yes.
If you can, yeah, I want to copy.
Okay. Okay. All right. Here's it. The D is from 224 to 239, and the E is from 240 to 255.
Thank you, sir.
You're welcome. So let me go to, okay. So there's it. Now that you've come to know the classes, or we are able to know those classes, now we have to now determine if it's a class E, which parts of the IP address belongs to the network and which parts belongs to the hosts. That's the machine on which you are operating. Because that is very important. That is very, very important. So let's see. In a class A, this is the principle. In a class A, only the first octet belongs to the network. The rest belongs to the hosts. For class B, the first two, the network, the last two, the hosts. In the class C, the first three, the network, the last one, the hosts. That's exactly how it's working. Class A, the first one, the network, the last three, the host. Class B, the first two, the network, the last two, the hosts. Class C, the first three, the network, the last one, the hosts. So I come back to this IP address I gave you here, this one. Now, I want to ask you, which portion of this IP address belongs to the host, the device on which it is assigned?
So
Portion
20.
of it. Which part of it?
The last one.
Excellent. Good. 30. Yes. 30.
30.
That's good. That's good.
30.
While the first three, 194.20.26, belongs to the network itself, which means that every particular machine which is found in the network with this particular one must all have the same, the three, like this: 194.20.26. Like you have 024, 024, 024, 054, 054. The same principle applies here. The network part is the same for all the machines that are found in the same network with this one. Then let's go to this particular one at the top, the one here, the 10.168.10.9. Now, for this one, which part of this network, which part of this IP address belongs to the network?
The 10.
10. Excellent.
The first 10.
Excellent. The first 10. Now, this is the principle behind it. Okay. Having known this, you will be able to assign the IP address as well. Now, I believe you have written all of them. So let me give you an example. Let me state something here. Assuming we have a network like this, let me try to use this. Okay. So let me just go this way. This is my network. Okay, Christian. Yeah.
Yes, sir.
That's
So
okay.
please, sorry. With the IP address, I just entered to see something, and then though it gives me the reply from 127.0.01, then bytes 32.
Yes.
Then it says time 1 ms, and then we have TTL 128. I don't can you kindly those what is the meaning of those TTL equal to 128?
Okay. Now, when you tell time to leave, usually it's called time to leave. No, these guys, these things have their own way of getting things done. The TTL means time to leave. That means that it's referring to the time that is taken by the packet to get transmitted from the system. Of course, there's a way it measures its own time, that time. Then the byte is referring to the size of the ICMP message, which is granting you, which is bigger than you. Okay, but the TTL, then the whatever time 1 ms TTL, it has its own way. We call it time complexity. It has its own way of dealing with these timings, and it's mostly of the same trend, most often of the same trend, with the nature of the packets which are being sent. Now let me show you. You understand this better when we begin to deal with packets itself. Well, I mean, how packets actually travel networks. That is when you understand better. Together. Okay.
Thank you, sir.
Yeah, you're welcome. Okay, so let me give you this example to you. 192.168.8.10.4. Then 192.168.10.8. Then 192.168.14.7. Then 192.168.10. Let me see. 186.10.100. Now, this one is computer A. This is computer B. This is computer C. And this is computer D. Now, I have established a network and placed these machines in one network. My question is, will all these machines be able to communicate with each other? As a network consultant, I am asking you, will these machines in this network be able to communicate with each other Look at it carefully and critically and tell me the answer. If yes, why? If no, why? Okay, Joseph.
I'm only trying. I mean,
Just
I think yes, because they are
the-
all on the same address
okay, okay,
or the same host.
okay. So they are all on the same address. That's what Joseph is saying, and for that reason, they will be able to communicate amongst each other. So basically, they're saying they are all on the same network. Okay. Any other addition to what Joseph said? Is it still yes?
Sir, please,
Mm-hmm.
if they are, he's saying they are all with the same address. What of the last digits?
No, that's
The
what.
last digits are different.
No, I've not actually said yes. Answer is correct.
No, I'm not. I wasn't referring to you, sir. I'm just asking what my brother said. Though I
Okay.
wasn't. I am not in agreement with that because
Okay.
though the first three digits are the same, but the last digits are different.
Yeah, the last digits are different for all of them.
Yes, please.
Yeah, but he's saying that they are all in the same network. Of course, I should have asked him to explain to do more, say more about why they are all in the same network. Though, but I didn't ask Joseph actually. That's what he said.
Yeah, I'm saying they are all on the same network because when we look at the class, they are all under class C.
Okay, that's his point. Point is that they are all in class C. That's why he said they are all the same network. I don't get it. What he said. So, Prince, I hope you are still in line with him. Christian. Okay. All right. So, anyone has a different answer to this question? Okay. So, that's my answer. The answer is that it's a very big no. You can never have them communicating to each other. It is never possible. Okay, Clifford.
Sir, when you look at the IP addresses, you realize that all of them have different host addresses.
Yes.
And
They all have
since
hosts.
they are class C, it means the first three should be that of the network. So it means the third IP address is in a different network.
Which one?
The 192.168.14.
The C. Okay. Okay.
That network is different from the rest.
Good.
Though the other three has the same network addresses, but the host address are different, so it is impossible.
Okay. 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 All right. So let me quickly get it in here. C, class A. So let me just ask you basically, looking at all these classes of IP addresses, all these addresses should be, actually it's a class C IP address because they all start with 192, 192, 192, 192. So we expect that they are all class C IP addresses. That's well established. So if they are class C IP addresses, sorry, the only thing which we are expecting to be different from each other is the last octet, the host part. For the host part, we can never expect it to be the same for all of them. Now, if they become the same, there's what we call IP conflicts. It will not work. So the only part of the IP address which should be different for them all should be the host part. This, and this. The first three, because it's a class C, must remain the same for all of them. And mind you, the fact that it's a class C doesn't mean that every class C IP address, all class Cs can work in the same way, even if it is not, because you can still have 193, 194, 19 this. So it is not that all class Cs must be in the same network, no. But then it is that if it's a class C, then the first three must be the same. So see this. 192.168.10. Yes. 192.168.10. B. Also correct. So which means that it is established the first two here can connect perfectly. Now look at this one. 192.168.14, not matching with the 10 here. So because these three here are not the same as the three here, this machine here cannot connect in this network. In fact, it is not, it can't be part of this net, even though it's a class C on its own. You can have this one as class C, this as class C, this as class C. But because it's a class, this class C is not part of this network, this guy here cannot communicate with the rest of the guys here, because the first three here is not in match with the first three we have known before. Last one, 192.186. This is 186. This is 168. 168. 168. Now that alone has deviated the whole equation. So this last one here can't also connect with this device here. In this case, C and D cannot communicate, but A and B can communicate effectively because they have their network part being the same. Clear? So let me do this. Let me quickly do this. See what I'm going to do here. 168 here, 168 and 14 here. So it means that A and B can communicate. C and D cannot, and C and D can also do. So this one, to get it done, you must get two different networks. This is in one network, and this two is in another network. Because there are three here are the same, and these guys too, there are three here are the same. So they are both found in two different networks. Clear? Is it clear?
Yeah, it's clear.
Okay, okay. So that's the nature of how these things really work. This is how these IP addresses work. Of a network administrator. Okay, that is what they are expected to do in order to make sure IP addresses are effectively distributed on our network. That's what they do. So this is how we assign them, and this is how we operate with them. Now, let me do this quickly before we end. In fact, we may have to end early. We are trying to see if we can meet Godwin tomorrow evening as well.
Sir.
Yes.
I also have a different way of looking for an IP address, either be it on a laptop or a phone.
You mean what? You want to find its IP address?
No, I mean there is another way of finding it in case you don't know. I mean, like I want to find somebody's IP address or where the person, the location and stuff.
Okay.
There is a website for doing that.
So share, do share with us.
Okay. Please, if I will give it to you, then you log in, then we'll do this thing.
Okay.
That is, you go to Chrome.
Okay. I mean, I should do it with you.
Yes, please.
I should we do it together.
Yes, please.
Oh, okay. Then let me get my Google here. Okay. All right.
Okay. So take your time with the process. Some of us are interested in the process.
Which process?
How to find IP address? What process?
Okay, so, this is very okay. So you type WHO, WHO.
Okay, WHO.
Yes.
Who am I?
ER.
Okay.
ER.net.
Whoa.
Yeah, whoa.net. Then you put .net.
Okay.
So you enter. It will tell us your location where Ghana, your connection is private. So
it's not private.
but when I do it, I just
Yeah, I can still find my way. Okay, well, yeah.
I should share my screen.
Okay, yeah. No, but if you do, it will tell you a lot about what is all right.
Yes.
But then, you're right. But then let me say, okay, I was going to ask you what network you're using, but you see, this is actually something that concerns security. Trust me. Now, what means is that for me, currently, if someone comes to use my machine to get to that one and go, this is what he will be seeing. Unless, of course, the person comes here and does this. Have you seen? This is my IP address. These are my IP addresses I'm using now. I entered IP config and it's giving me the different what I'm using: the default gateway, the subnet mask, the IP address, and all the others are all shown here. But then, how to go online to do the HUA? In fact, security-wise, that's why my system is blocking it. It's not allowing me to go there because security-wise.
Okay.
It's a corporate thing. You get it?
Yeah, it is used by boys, so that's why.
Who's by my voice? Which voice?
Later we'll talk about that one.
Okay, fine. But it is something which is not necessarily you see you shouldn't find other people's IP address. Okay.
Very necessary.
Yes, a site is made available just to ease some of these things. But in a typical corporate system, corporate network, it will block some of these sites from getting in there because it is not it's a breach of security. Okay, that's why when you were saying, I was asking, do we have to do it together that we all see? Yeah. But the fact is, here as we see now, I can bypass the security here and then get in there. But of course, as much as yours is working, so you know that yours has bypassed it and it's working. Okay. But then it is not a general means by which you can find your IP address. This one can help you find other people's IP address more likely. Yeah, but security-wise, it is a breach of security though. But of course, studies to be a good security expert, you must still be a hacker as well before you can get in there. I mean, for a good reason though.
Information security.
Information security. But I'll teach you more security in this course, okay? I'll give you a lot of security stuff in this course, a lot of that, trust me. Yeah, I'll teach you more security in this course. Yeah. Okay. So that is it. That's what we're talking about here, all this well. But let me just give you this last one. Every IP address also comes with a default subnet mask. Now, the subnet mask is like something which will also aid in determining the network you're part of. Okay, it helps to determine the network you are part of. That's what we call a subnet mask. So every IP address has a subnet mask. So for class A, for instance, let me go back to that thing. The one I did. Don't go back there. Now, so for a class A IP address, for instance, let me show you this one as a demonstration. How do you see? Look at this carefully, quickly. I'm trying to get to the network part of it again. Okay. Let me get this one here. Then properties again. This is version 4. Now look at this carefully. Let's all observe it. When I enter class A IP address 10, then 12.4, then 6. Now look at this. I'm going to move the cursor from that particular zone. Look at what happens in the subnet mask. I will not enter anything, but look at what happened. Okay, let's see. Now what happened there? What do you see there? What do you see there?
Yeah, another IP address.
Yeah, but this one is 255.0.0.0. So the default subnet mask of a class A IP address is 255.0.0.0. Now, if it's a class B, let me just use the class B 191 and see what happens. Let me clear this from there first. So then I just enter 191. Let's say 191.12.45.1. Then I enter here again. See, that's changed. It is now 255.255.0.0. So the default subnet mask for class B is 255.255.0.0. It seems like the 255 is matching the network part, and the 0 is matching the host part. That's the obvious observation. Then lastly, for class C IP address, so that's 192.45.40. Then you enter here, you see it. Now 255.255.255.0. So every IP address you assign comes with a default subnet mask. It is also strengthening it being part of a network. So I told you from the earlier time that there are two ways of knowing which part of the IP address belongs to the host and which part belongs to the network. And I said the classes can be used and can also use subnet mask. Now the classes has it that the first octet for class A is the network. The subnet mask also has it that the subnet mask, the first one is 255 and the rest are zeros. So the 255 is always matching the network portion and the zeros are matching the host portion. That's how it works. Okay, so for now, what we've done here today is more basically having to know the devices which we use to set up a network. Now, having used these devices, when the network is done, hardware, infrastructure are all laid, you must enable communication amongst them. That is the responsibility of the IP address. Now, when we meet again, God willing, this week, what we'll do is that, how do I, with these IP addresses, how do I break, see, when you go to, when you make your company, and you go to the ISP that you want to really get internet in your company, they won't just, they'll ask you, okay, how many machines do you have in your company? Then you may tell them there will be 20. They won't give you 20 IP addresses. They will give you a single IP address. When you come into a company, you will now use your knowledge in network administration to now break it into many. In fact, even to break it into different networks as well. And that's what we'll be doing next when we meet. I won't add it to this one. It may be overload on you. So that will be the next thing we'll do when we meet again this week. I'll be in touch with the course rep and it will let you know, at least by this evening, you should be able to know exactly when we are meeting again, either Monday or some day. Yeah. So is there any question to be asked? What you've done so far? Okay, Prince.
Sir, please, can you go back to where you use the command prompt to check whether your IP is working or not? I want to try something.
Okay, let me. This one.
Yes, so you help us with how to check it since.
If your IP, your distance working, your how do you call it?
Actually, so you showed us how it works, and I wanted you to go back and then do it again so that those who couldn't catch it.
Okay, let me increase the font so you can see it big. I feel it's better. So, yeah, I'll get a slide for you, but let me quickly do this one for Prince. What I said earlier was that I want to know if my network interface card is operational. You call it self-check or self-test or loop backing. Okay, and the IP address we use for that is 127.0.0.1. But the command we use to do that is called the ping command. So we ping this IP address. Ping is a troubleshooting tool which we use to do a self-check or a check on a different machine to see if it is well connected or if the network interface card is operational. So it is this I entered, pin, then I entered, then I'm getting replies. Does it? Is that okay, Prince?
Yours is okay, but when I tried on my machine,
what happens?
It says ping is not recognized as an internal or external command.
You should go and buy a new machine.
Did you type PING? Did you look at it carefully?
Yes, please. PING.
And do you leave a space between ping and the IP address?
Yes, please. Space 127.0.0.01.
Come on.
No, sir. Is it .01 or 0.1? You made a mistake over there, but
it still works.
It still works. Yes.
But usually the 127 here is what it's used actually mostly.
Okay.
Because of the class A nature, it's still works. But then if it's not working, it means that the ping tool is not on the machine, and this is very common of Linux machines. So what I can tell you to do is that you can do the installation. Okay, you can do the installation on it. Then you can get it undone. Or better still, what version of Windows are you using?
Come again, please.
What Windows version are you using?
11.
11.
Yes, please.
Oh, okay. Okay. Should be able to do it. Let me see something. Where ping? Okay, so see, my ping here is in the Windows system.2 ping.exe. That's where it is found.
Okay.
Okay. Now, if you find it, sometimes if you find it like this, you can copy that whole thing and maybe just type it into a folder you have opened. Okay. If it works, you can run it directly or something.
Okay. Then I think I have to find where my pin is again.
Yes. Then you can also do the maybe set. Usually, if it's happening that way, it can also be from the what we call the environment variables. Sometimes. I think maybe I'll deal with this with you. Maybe at the back, whatever at the back. You can chat with me. You can deal with this. Okay.
Okay, sir.
Yeah. Okay. Any other questions so far?
Sir, please. This is not a full question though, but it just for you to help me something.
Okay.
I had a Google Pay ad where I want you to, if there is a software to bypass it and use it, please. Thank you.
Okay, okay, fine. I hear. I've heard you. I'll do that one.
Oh, please, just help us right now.
I can't help you right now. I can't help you right now. You see, let me
go and pay. Go and pay.
Let me tell you. Let me tell you. Some of these things are okay. Yeah, some of these are okay. But you see, my maybe I'll tell something. But my area of specialization in computer science is cybersecurity. Okay, so sometimes all of these things are things we are all trying to find ways and means of controlling. Prevent controlling. So it's, but as I said, we'll deal with this at the back end. Oh, I really have full-time hackers here. Oh, I see. I see. The full-time hackers are existing in this course. Oh, I see. That's not hacking.
Oh my word,
that's fine. But if you hack with a good intention, it's good. We call them white hat hackers or penetration testers. If you do a hacking with a good intention, it's good. I mean, but to destroy is not the best at all. Yeah.
So where good intention means?
Good intention means you are seeking to protect. Okay. Let's say, for example, maybe in a personal network I find myself in, I try to do some few hackings in there to find where the loopholes are located. Then I advise the company on it that, look, I have found these loopholes in your company. Better so, can you just work on it with some patches? I get me. You can get some people to patch them. They advise, these are security experts who advise on vulnerabilities or loopholes that are found in networks. And it's companies today employ such people. Companies employ hackers to hack into their company's network to find loopholes and then help them to correct it. But to hack, to do dubious things now and there, I don't think it's a good thing. That's why we are trained. We have been trained to be maybe to deal with some of these things. Very important. Yeah, but as you actually said, you can still. We will talk at the back end. Anyway. Yeah. Any other questions?
Yeah, please, your number.
My phone. My what number?
Yeah, WhatsApp number.
Why would you want my WhatsApp number? Why do you want it?
Yeah, we'll do it back door.
I hear we do back door. I hear. But it's let me tell you something. When you go to the European countries, I mean the Western world, do you know that IPM phone numbers are seen as IP addresses? So, like in Ghana, for instance, I come and ask a friend, "Oh, John, do you have Kwame's phone number? I want to call him and talk to him." "Oh, I have it. Let me give it to you." This can never happen in the Western world. The Western world, without someone's permission and authority, you can't give their numbers to other people. Never allowed. But then, well, I'm not saying it is wrong. I'll give them to you. If your court knows it, I'll give it to you actually. Okay. But then the point is that generally, even an IP address can be a point where someone is able to locate vulnerabilities in other people's systems. It happens. That's why this mobile fraud and the mobile stuff now, it is as a result of numbers that are known everywhere. That's why it's now escalating every day. Yeah, but as you rightly said, we'll still talk at the back end. Someone's asking cybersecurity specialist. Yeah, since you've said this, let me just quickly say this. Some of you here, I will advise to take up professional courses here, even now. Start training yourself towards that. I've handled some few students in cybersecurity professionalism, where some of them have written the professional courses like CISSP, CCNA, and the likes. Yeah. Like ethical hacking and the likes. The point is, I'll advise it. If the interest is there, start getting yourself trained and get some professional certificates. And I would advise CISSP and CCNA. I would advise on these two. Get yourself trained, prepare yourself for this. It will help you. To really help you, both in the industry and in the academia. It will help you a lot. Yeah, but if I will still get you some materials to get you prepared for some of these things, I'll get some material for that. Yeah. All right. Have any question or contribution? Okay, if there's none, then I wish you a good week and hope to meet again this week before the week ends.
Yeah, please, the number. Please don't forget the number.
I'll let you have it. Don't worry, I'll let you have it. At the back end, I'll let you have it. Okay. Yeah, so stay safe. Bye.
When I was asking you of Google Pay app, you were laughing at me.
You want a cybersecurity expert to share his number with you here? You are joking.
That's a go and pay. Go and pay.
Don't tell me. You ask you whether we are able to download those AI something. You tell me. We are all in together. We are something together.
This year, go and pay for Google to get money. Go and pay.
Okay, sir. We are all something together.
After buying, you are asking for back pass.
So UCC will not release our results for us again, or what?
It has been hacked.
This tradition of
it will not go there.
Beginning another semester without seeing the results for the complete results for the previous one. Some of us, we don't know whether we are continuing or we are stopping.
That's we are all continuing. Nobody is stopping. We are all continuing.
There were instances where people were waiting to see whether they've gotten refers or not before they decide to continue.
Yeah, after their money.
Before they release it.
They are after their money, so they will not refer you. Even if they refer, they will. They will
They
make sure
want the
you
last
pay.
2,000.
Yeah, you fail and see whether they will refer you or not.
In fact, I need help. One of the courses that is color psychology. I learned it's released, but mine is still not too. So I don't know. I've complained to the secretary. Still, I've not had any listen. If anybody has an advice for me or where to reach out, then I'll
But
be very
you
grateful.
don't you have
You need to call the
the one
teacher.
who taught us number?
I spoke to him. He said everything that he even completed everything. So he's surprised all these things are coming back to him at this time. That all what he needed to do, that he has completed everything and submitted to them. That it was just like they even releasing it, but they delayed it till this point. So he was making the point that all other things that has to do with our results were supposed to have been done long time. So for now, all our issues are solved when it comes to his end.
Okay, Tina, have you checked the IC status site? If you have,
Yes. When you go, so that particular course, you know that
Mhm.
particular course, there was a quiz we didn't write on it. So you see that they will tell you quiz 2 not captured.
You still have quiz 2 not captured.
Yes, that is what is showing there.
Maybe that is why it's
And
not coming.
you know that particular course, we didn't write quiz on it. They sent a communication, we didn't write a quiz on it.
Color psychology.
Yes.
Yes, we did.
We did though, and
You did right, oh.
we wrote 1 and 2.
Yes.
We just that the teacher gave us some assignments to present to
Yeah,
him.
he gave assignments, but we wrote the quiz.
So maybe you need to go to the where you find the result site, where the support numbers down there at where the IC status is. So call any of the numbers and complain to them. They work on it for you.
Okay, let me follow up on that too and see. Thank you very much. I'm much grateful.
All right, bro. But Sir Clifford, you need to teach us this course. So.
Me that I'm on life support now. It shall be well. We'll go through.
Who was dominating? Who was dominating?
Prince Daco. Where is he?
Hey, Daco. Master in Photoshop, master in a network. Daco.
Network is a very nice course.
Yeah.
Mama, the lecturer didn't give his number. Christian. Christian
is off.
Okay.
Hello, bro.
Hey.
I did.
I heard my fire service on.
Hello, Crusader.
Player warrior. Player camp.
Hello, Crusade.
They are chanting down behind my door, master. They are chanting down for here. Me too, me Rasta, know the love, but they chant the Rasta down.
No, it's because you joined with 2 devices.
No, my phone and the laptop, I off the other one. The laptop, the speaker, the microphone is not working.
Oh, okay.
They are chanting me down like that too. I'm Muslim crack on my inner door plaster. They are blinking me down. Has he shared the slide, please?
Course rep is on it, so maybe probably he will get it for us.
Oh, okay. No be easy. Not easy for this course. We wish we get time to go through a lot, but time small. Flash.
Shall we all?
Positive.
All right.
There'll be a better time.